Hi friends! So for some time now I have been working on my Homelab rack. And during that process I have come across many issues that I think are universal to anybody who tries to build a Homelab rack. But there is one issue I have that I think either everybody has but doesn't talk about it or simply omits it. Don't you just hate this? So power delivery and power overall has been not necessarily a big problem, more of a cabling problem for me, but still it was something that kept itching in the back of my head. Why do I need all of those adapters? I need to power things like my ISP router, my Ethernet switch, my HDD enclosure, and quite possibly some other things that have this one neat single thing in common. They are all 12 volts DC power based. So I ventured on this journey when I tried to find one big power adapter that would allow me to plug all of those devices. And ideally, it would be modular to the point where I could, let's say, maybe use some other connectors than this. Another reason why I constructed my own power supply unit was actually this hard drive enclosure. Spinning plate drives may require 8 watts of power per disk during normal operation, but they spike whenever they spool up, especially during startup. And that goes for all the devices. Even if they require 12 volts, their amp demands may vary. So now I had to juggle between power bricks just to find the appropriate one for the device. And as you can imagine, that gets tiring really quickly. I couldn't find anything off the shelf that would be reasonably priced, so I decided to build my own PSU and spend even more money overall. But hey, I'm just having fun here. Big disclaimer, I am not an electrical engineer, I'm not Electroboom. You shouldn't treat this video as a tutorial on how to build a power supply. If you want to build your own, be very, very careful. Okay, so let's take a look at this thing. Overall, it consists of a case, main power switch, 100 watt PSU, custom PCB for power distribution, and some cabling. First of all, the case. It's a universal 1U case. I chose it because it was the cheapest I could find. Around $65 US. I really like the round cutouts in the back. I thought they would allow me to easily route the power cables out, but in hindsight, they're too big and not ideal for the use case. And I'll say this right now, cutting the holes in the case is by far the hardest thing to do in this entire build. I don't know if those can be ordered according to spec, but cutting out square holes for the main power switch was an agonizing process that took me 3 days. Because I was using miniature handheld multi-tool for cutting. I don't have access to CNC, but if you have any better idea on how to tackle this, I'm open to suggestions because I already have more ideas on how to improve this thing, but sadly they include cutting more holes. I am getting ahead of myself, so let's talk about the PSU. The main heart of the unit, in my case, is the integrated 100 watt PSU. I calculated how much power my current devices draw and added 30 to 40 watts as a buffer. Ideally, you should look at how efficient your PSU is, and not only that. PSU efficiency is a curve, so they are most efficient around a certain power load. For example, let's assume 100 watt PSU, like this one here, has 80% efficiency under full load. That means it draws 125 watts from the wall and wastes 25 watts as heat. Old formula says that PSUs are the most efficient at 50% power load, but that gets pushed higher the better PSU is rated. You know, the 80 platinum, 80 gold, stuff like this. Anyway, it's worth checking out the PSU efficiency value. Also, be wary of cheap LED PSUs. They can be made using low-quality components or use primitive methods of rectifying. As a result, they may output dirty power that's not a flat 12 volts. With precise and delicate electronics, it might have an effect on them. It's difficult to verify how good your power supply is without an oscilloscope. So if you have access to oscilloscope, it's worth checking. At this moment, heat produced by the power unit isn't a problem, but if it ever came to that, I can always install a simple fan. And I also have a lot of ventilation openings already cut in the chassis. Oh, and one more thing. I haven't done this on purpose, but you can buy a buffered PSU. It looks almost identical, it only has some different outputs right here, but it supports connecting a battery as an external power source, effectively changing this whole thing from PSU to UPS. Before I talk the power breaker board, quick note about the main power switch. It has an inbuilt power breaker which serves as another way to protect myself in case the PSU has short or fails in some other way. Now, the PCB is something that took me a long time to find, mostly because of how I wanted the breakers to work. Industrial stuff is very expensive or comes with non-swappable breakers for very low currents that wouldn't satisfy my hard drive enclosure. So right before I started designing my own PCB, I found a local seller that produces those boards. It splits main power from the PSU into 9 protected outputs. It's a simple design, but every output has its own dedicated breaker that can be swapped according to your needs. Currently I have 3 amp breakers for every connected output and the rest of them has 1 amp breakers. And that's pretty neat. In case I want more power directed to something that's actually more power hungry, I can just replace the breaker right here. It also has lights that indicate whether the breaker is okay. It's very handy for debugging or checking if everything is alright. But in order to attach this PCB to the case, I had to buy some spacers and screws, which didn't turn out to be ideal because they stick to the bottom of the case. Ideally, I need to come up with something better, but for now it's fine. From what the clerk at the store told me, that in the factory they push out the holes instead of drilling them and then they only thread them. So you have already like threads to screw in the nuts and bolts into it. Okay, so you would think the cabling is the easiest part, and you would be almost right. Red is plus, black is minus, just don't pick floss thin wires for the main power rail. Everything complicates when you reach the DC power stage, basically this thing right here. Essentially, it has to have correct polarization. So if you swap positive and negative right here, you can fry your device. So it's crucial you check the very connector you're plugging into the device. Never trust standards or good practices at this stage. Always verify, always check which one is plus and which one is minus, in cables like those especially. It's always cheaper to sacrifice 10 seconds to check with a multimeter rather than possibly hundreds of dollars in connected hardware. This custom PSU is just the beginning. I've got my sights set on some seriously advanced features next, like real-time power monitoring across all rails. It'll be a challenge to keep the costs down while achieving that level of detail, but I'm up for it. If you have any suggestions for this project, write a comment. I am always reading every single one. Don't forget to like and subscribe if you want to see how this thing evolves. As for now, that's all. Thanks!